Okie dokie, we're ready to move on in chapter 1, or topic 1, I guess they call it in these books. Lesson 1.6, use properties of integer exponents. There's a lot of words there. Properties are kind of like the laws or the rules of math about why math works the way it does. And so we've got lots of properties. You know a lot of the properties, you use a lot of the properties on a regular basis. For instance, one property that I know you guys know and are familiar with would be a property called the commutative property. So the commutative property of addition says that 3 plus 2 is the same thing as 2 plus 3. Okay, that's a property. All right, and that's pretty simple, and it's easy to understand. But it's like one of the rules that says math has to work this way. If math doesn't work this way, then it doesn't make any sense. So if 3 plus 2 gave you one answer and 2 plus 3 gave you a different answer, well, then math would get way harder, right? Because you'd have to know some weird stuff then. So the properties are kind of the things that set the rules in place for why and how math works the way it does. What does the word integer mean? What is an integer? What kind of number is an integer?
Odd. Sleep form.
Are they whole numbers or are they fractions?
They're fractions.
Nope. Whole numbers, can they be positive or negative or both?
Both.
Both, okay, so integers are positive and negative whole numbers. And then, do you know what an exponent is? Yes, exponents are like the numbers that go, that are that superscript when you have like, we've been doing exponents the last couple lessons, by the way. So 2 cubed, which one is the exponent?
2. Or cube.
The 3 is the exponent, right?
Oh, yeah.
2 is called the base. The 3 is the exponent. And together, as a unit, they're called a power. It's a power. Okay, so we're going to use all those words in this lesson today. So you need to know what a base is. A base is that number that's the number that's being multiplied, the factor that's being multiplied over and over. The exponent is the little number in superscript that tells you how many times that factor is being used. And then together, they are called a power. All right? So that kind of lays some background for what we're going to be doing today. And here we go. Let's jump in and do our warm-up question. All righty, I like my guy here on this page 41 in your books. He has got it going on. Little air guitar going. Okay, so one band's streaming video concert to benefit a global charity costs $1 to view. The first day, the concert got 2,187 views. The second day, it got about 3 times as many views. On the third, it got 3 times as many more views. As on day 2, the trend continues. How much money will the band have raised in 1 week? So we need to kind of do a little math here, don't we?
Yes.
Okay, so we can think about the number of days that we're so how many days are we talking about? 7. We're talking about a week, right? So we're talking about day 1, day 2, day 3, day 4, day 5, and 6, and 7. I can't write really down here at the very bottom of the page. So we'll fix that at the end. So on day one, how many people watched the video? 2,187 people. And I don't want to know the number of people. I just want to know what we would do to find the number for day 2. Multiply it by 3. So we would take our 2,187 and we would multiply that times 3. Okay? And then what about day 3? we would take this, whatever this number is, and we would multiply it by 3 again. So we could just do 2,187 times 3, and then times 3 again, right? And then what about day 4?
Just 3, 3, 3, 3.
2,187 times 3 times 3 times 3. Do you see a pattern developing here? 2,187, this is day 5, times 3 times 3 times 3 times 3. And day 6, 2,187, oops, that's funny looking. 2,187 times 3 times 3 times 3 times 3 times 3. Any surprise about what the last one's gonna be? I'm gonna squeeze it in down here at the bottom. 2,187 times 3 times 3 times 3 times 3 times 3 times 3. Man, if only there was an easier way to write that.
There
Is there? Are you sure? How would we write it in a simpler way?
Power.
With a power. Okay, we can take this one, and I'm gonna put it up here where it's easier to write. I've got more room, and I can write it as 2,187 times what?
7, 6.
6.
How many 3s are there?
Well, 6.
Six.
3 times 6.
3 times 6?
3 times 6 is 3 times 6 is 18, so 8.
How many 3s are there as factors?
6.
There are 6 of them, so times 3 to the 6th power.
Oh, I thought we were
Okay.
gonna make it. Okay, I'm out.
Okay, so 2,187 times 3 to the 6th power. That's shows us why using exponents is just kind of a handy thing to be able to do. If we know how to use exponents, it can make our mathematical expressions much simpler to look at and much simpler to use. Because if I had to write this out every time I wanted to do it, well, this is way simpler, right? Okay, so that's just a little kind of reminder about how exponents work and what we use exponents for, right?
Yeah.
Okay, so you guys are you comfortable with exponents so far doing this? Okay,
Yes.
this is the kind of thing we need to be able to do with exponents. All right, let me move to our next slide, which is, you know it, it's a video. I gotta tell you, this video's pretty good. I like this video. There's gonna be another one, which frankly, I don't care for a whole lot, but we'll watch it anyway because it sets us up for some other stuff. So, this video is pretty good. Here we go. Why won't it play? There we go.
How do properties of integer exponents help you write equivalent expressions? Think about this question during the lesson. Here is an adult male caribou with a young male. The average weight of a newborn male caribou is 2 cubed pounds. On average, an adult male caribou weighs up to 2 to the 6th power times more than newborn. How can you determine the average weight of an adult male caribou? To solve the problem, look for relationships. Ask yourself, how do the two weights relate?
16.
The adult male weighs 2 to the 6th power times more. The two weights are related by multiplication. The average weight of a newborn male caribou is 2 cubed pounds.
8.
How do you write 2 cubed in expanded form?
2, 2, 2.
All right, expanded form. So if we have it written in exponential form here, 2 to the 3rd, what would it look like in expanded form? 2 times 2 times 2. We would just write out what 2 to the 3rd means. So 2 to the 3rd power means 2 times 2 times 2. Expanded form, we would write that out. Okay, so here's what they're gonna do that for us now.
In expanded form, 2 cubed is written as 2 times 2 times 2, which is 2 multiplied 3 times. Now, let's move to the adult caribou. It weighs 2 to the 6th power times more than the newborn, which is 2 multiplied 6 times.
16.
Find the product of the two expressions. The weight of the adult caribou in pounds is 2 cubed times 2 to the 6th power. What is the exponent of the product in simplified form? Select your answer.
So, we've got 2 to the third, time for lunch for some folks, 2 to the third times 2 to the sixth. So, 2 to the third times 2 to the sixth, how many 2's do I end up having here?
3 more.
1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 to the third times 2 to the sixth ends up being 2 to the ninth.
When you join the two expressions, 2 is multiplied 9 times, which is equal to 2 to the 9th power. There's a pattern when you multiply two exponential expressions with the same base. We can use the product of powers property. 2 cubed times 2 to the 6th power is equal to 2 to the power of 3 plus 6, which is equal to 2 to the 9th power.
Okay, so this is our first property, and its name, the name of the property is product of powers property. What does product mean?
Multiply.
We're multiplying. So we are multiplying two powers, and the two powers have the same base, right? 2 is the base here, 2 is the base here. So the two powers have the same base, and when you multiply those two powers, the property says you add the exponents. Okay, so when we multiply two powers that have the same base, we add the exponents. That's the rule. Everybody with me?
Yeah.
Okay, if that's all we were doing today, that'd be pretty simple and the homework would go fast. But we're gonna add some more properties in, and because we're doing more than one property at a time, and frankly, the names are very, very similar, it gets a little bit confusing. Okay, so it's easy to turn the names around. In fact, we're gonna see one in a minute. This is product of powers. We're gonna see a power of products. Who does that? Mathematicians. All right, so here we go. Start the activity. So which of the which of the following expressions are equivalent to 3 to the 12th? 3 to the 12th.
That'll be.
We don't know. 3 to the 12th?
I can't see.
It is hard to see.
3 times 7.
Ooh, when you multiply the bases, what do you do with the exponents? What does the rule say to do with the exponents?
Add.
You add the exponents. So if I add the exponent 3 and the exponent 4, that would be 3 to the 7th.
So it's
So that one actually is not equivalent.
1.
3, 4, and
3
3.
to the 4th and 3 to the 8th, you add the exponents, so 4 plus 8. Elliot,
6 and 6.
okay, 3 to the 6th times 3 to the 6th, add the exponents, 6 plus 6 is 12.
2 and 10.
And Bryson? 2 and 10, 3 to the 2nd times 3 to the 10th, 2 plus 10 is 12. What about 3 to the 6th times 3 to the 2nd? That would be 3 to the 8th. And then 3 to the 1st times 3 to the 12th?
Non-equivalent.
That would be 3 to the 13th, so that is not equivalent. All right, so the solution is gonna tell us we did it right, because we are super smart. Okay,
Thank you, Mr.
All right.
Fish.
that video's done. Now let's look at
Hey.
A.
You put like a rubber tip on your ruler, man. Click the arrow.
I think it was, I don't know. Do you have anything else? Am I missing something? Or was it that was the activity, wasn't it? I don't know. Let's try this. There we go. Now it worked. All right. The local zoo welcomed a newborn African elephant. The newborn weighed 3 to the 4th power kilograms. It is expected that at adulthood, the newborn elephant will weigh approximately 3 to the 4th times as much as its birth weight. So what expression represents the expected adult weight of the newborn? So if it starts out at 3 to the 4th, and then it's going to grow to be 3 to the 4th times that much.
3 to the 8th power.
There you go. We keep the same base. The base stays the same, and we add the exponent. So it's 3 to the 8th. Pretty simple. I mean, the rule is simple. You just got to remember not to get confused. Okay? So 3 to the 4th times 3 to the 4th is the same thing as 3 to the 8th. Explain why it makes mathematical sense. Because this one tells us we're using 4 factors of 3. So 3 times 3 times 3 times 3. That's 4 factors of 3. This one says we're using 4 factors of 3. So times 3 times 3 times 3 times 3. So that would be a total of 8 factors of 3.
That's a lot.
Right? So that is 3 to the 8th. All right. We good?
Yep.
All right, so that's the product of powers. Let's learn a new one, multiplying exponential expressions if the bases are different. So for the product of powers, the bases have to be the same for that property to work. But what happens if the bases are different? Well, let's watch this video. This video is not as great as the last one, I think, but we'll still get some stuff out of it.
Find the volume in cubic inches of a cube with edge length of 2 feet. The volume of a cube is equal to the edge length to the 3rd power. The edge length of this cube is 2 feet. So the volume is 2 to the 3rd power cubic feet. To solve this problem, first find the conversion factor from cubic feet to cubic inches. Here is a cube with edge length 1 foot, so its volume is 1 cubic foot. 1 foot is equal to 12 inches. So divide edge length of the cube into 12 1-inch sections and divide the cube into 12 to the 3rd power tiny cubes. The volume of 1 cubic foot is equal to 12 to the 3rd power cubic inches.
Okay, so this one is, we're changing, basically we want to convert from cubic feet into cubic inches. So they're giving us a conversion factor and kind of taking a long way to get there by drawing us a nice picture and everything. The math works, you just don't get lost in what she's saying, just look at the numbers and what they're doing.
Now use the conversion factor to convert 2 to the 3rd power cubic feet to cubic inches. Substitute 12 to the 3rd power cubic inches for cubic feet into the equation. The volume is equal to 2 cubed times 12 cubed cubic inches. Now evaluate the product of 2 cubed and 12 cubed. One way to begin is by using the definition of exponents to expand the product. Now use the associative and commutative property to rewrite the product. The product is 2 times 12 times 2 times 12 times 2 times 12, which is equal to the quantity 2 times 12 to the 3rd power. This result shows the power of products property. When multiplying 2 exponential expressions with the same exponent, such as 3, and different bases, such as the bases 2 and 12, multiply the bases and keep the exponent the same.
Okay, so now we've got the power of products. This time, we've got different bases, but what's the same? What's the same?
The power.
The exponents are the same, right? So this rule applies when the bases are different, but the exponents are the same. The last rule, the bases had to be the same, the exponents could be whatever. So we've switched around the words. We had the product of powers. Now we're switching the rule around. Now we've got the power of products. Okay? So as long as the exponents are the same, we still can deal with the math. And here's how it's going to look at the end.
Now simplify the expression. The product of 2 and 12 is 24. So the expression is 24 to the third power. A volume of 2 cubed cubic feet is equal to 24 to the third power cubic inches.
Okay, so now with this rule, we keep the exponent and multiply the bases.
Yeah.
Okay? With the last rule, we kept the base and added the exponents. Now, we multiply the base and keep the exponent. That's confusing. But the rule is what the rules are what the rules are. We just gotta keep the rules straight. Okay? So, and this one, there's not even like any, we're gonna get to some examples here in a minute, but they just kind of move us on to the next rule. So they gave us one little video and explained the rule. Now we're gonna move on to the next rule. Okay? Now, we're gonna talk about the power of a power. So we've had the product of a power, we've had the power of a product, now we've got the power of a power. The power of a power is we've got a power, 5 squared, that has an exponent. So you have an exponent with an exponent. Okay? So now, think about this, and they give us the explanation. This is in your book here. So we can expand 5 squared to the 4th power. 5 squared to the 4th power is the same thing as 5 squared times 5 squared times 5 squared times 5 squared. We know what to do with this. This is product of a power. Okay, we keep the base and add the exponents, and it comes out to be 5 to the 8th. Now, what could we have done to skip this part where we expand it all out? How do we get 5 to the 8th out of our original expression?
It just times the 2.
Just multiply the exponents, okay? So if you have an exponent with an exponent, you multiply the exponents. Keep the base, multiply the exponents. That make sense? It's not a hard rule, just gotta keep it straight and not get confused with all the others, right? Okay, so to find the power of power, multiply the exponents. Here we go. They're not gonna give us any examples here. We're gonna jump straight to the next rule. We've got one more. All right, now it is the quotient of powers. What's a quotient?
Good question.
What are we doing here?
Dividing.
Dividing. Quotient is division, okay? So, think of it this way. If you had 6 to the 5th divided by 6 to the 3rd, 6 to the 5th is 6 times 6 times 6 times 6 times 6, yes?
Yeah.
And we can do division, make it look like a fraction. So it's 6 times 6 times 6. And anything on the top of the fraction can cancel anything on the bottom of the fraction. So what am I left with?
2.
6 squared. So how can I get 6 squared out of my original expression?
By doing that.
Well, but without expanding it and writing all that out, how can I look at this and get 6 squared?
Use minus.
Subtract, okay? When you multiply bases, you add exponents. When you divide bases, you subtract the exponents. So the bases have to be the same, and we're gonna keep the base, subtract the exponents, okay? All right, clear that, next. Okay, we write it as a fraction. We kind of went through these steps already. There we go. The quotient of powers property states that when dividing two exponential expressions with the same base, subtract the exponents. All right, and then we get some examples to go through. All right, so 7 to the third to the second. That's a power of powers. You have an exponent with an exponent, Bryson? 7 to the,
6 power.
when you have an exponent with an exponent, you multiply the exponents. 7 to the 6th. How about B, 4 to the 5th to the 3rd?
4 to the 15th
That'll be
power.
4.
Keep the base, multiply the exponents. Multiply the exponents, because it's power with a power. Alright, what about C, where you have 9 to the 4th times 8 to the 4th?
72, 8.
Rip, we've got to multiply the bases, since they're different bases, but they have the same exponent. Keep the exponent, 72 to the 4th power. And then D, 8 to the 9th divided by 8 to the 3rd.
8 to the 6.
Keep the base, subtract the exponents. 9 minus 3 is 6.
That's pretty easy, Mom.
Wow, well, any one of the rules is not too bad, but when you they can kind of get jumbled up if you let them. So, just try to keep them straight. The first couple of problems on your homework, we'll go through those here in a minute. Those fill in the blank ones are a pain in the neck. They're confusing. And then we'll get you started. All right. Let me shut this off.